Already we have discussed about dropout regularization and L2 regularization. We are using these two regularization methods in order to overcome the overfitting problem and to reduce the high variance. So already we discussed there is another method whenever we want to reduce the high variance, that is by taking the more number of training samples. But if we don't have more number of training samples, already our training data is exhausted, we have searched for everywhere, and it is it is very expensive to take the new samples. Then there is a concept called data augmentation. By using this concept, you will get the new training samples from the existing training samples. How to get the new training samples from existing training samples? You observe there is a cat image here. Now I am flipping this image horizontally. So this is one training example, this is another training example. I can also zoom it, and after zooming I can crop some area. Now it is another training examples. Now from using one training example, I got another two new training examples. Remember, you should not vertically flip it, then it will predict some other wrong information. Now there is a handwritten, or there is a number 4. Okay, there is an image in which a digit 4 is there. I can distort the 4 and I can give 3 more new training samples from the existing training samples. This is what we are calling as data augmentation. This is useful to us as it is very inexpensive process. There is no need to go there is no need to go to the field and to get the data from the users, or to get the data from the field. But instead of that, by using the data which we have, we can simply do some modifications. We can, by flipping horizontally or cropping it or distorting it, by changing sometimes background, by adding different noises, we can distort the data. We will take that as an input for the new training samples. Whenever these number of training samples are incremented, then because of the increment of the training samples, now we have decremented the variance that causes to avoid the overfitting problem.